Good afternoon. The next one is RAID level 3. Even in RAID level 3, bit level stripping only is followed. As we already told, first bit will go to disk 0 and second bit to disk 1 and third bit is to disk 2 and so on. Now, instead of using Hamming code, we are using parity to maintain the redundant data. What happens? Keyword is the number of disks we required in order to store Hamming code will be more when compared to store the parity data. When we are calculate the parity and maintaining it in a disk, we required only one extra disk when compared to the data disk. In comparison with the Hamming code will be requiring long number of data disks in order to maintain the Hamming code redundant data. Here, what happens when we are performing a read request or write request? In all the data disks are required to access when you are supposed to read a particular data. When you are writing a data, then all the disks including the parity disk need to be accessed, so only one request can be serviced at a time. Now, RAID level 4. In the case of RAID level 3, we can see we are using bit level stripping, but in the case of RAID level 4, we use block level stripping. Block level stripping. Block will be having one or more words actually. So what happens? So let's see. Consider each having one word. Each having one word. In the case of bit level stripping, when you are considered one word bit, it will be going on another bit and another bit and another bit here. But in the case of block level stripping, if block is considered as one word, one complete word will come here, second word, third word and fourth, like this it will be coming and parity will calculate it using all the blocks, block 0, block 1, block 2, block 3 and store the data here. Like this, the parity will be calculated in the RAID level 4. Here also, only one extra disk will be required in order to maintain the redundant data. One advantage in the case of RAID level 4 is if read request is smaller than the stripping unit, then we can access only a single data disk. But if you see in the case of RAID level 3, we have to access all the data disk in the case of read request. But in the RAID level 4, there is a chance to access only a single disk or two disks. It depends upon the data size we are going to performing read request. In the case of write request, we have to update the requested data block and also the parity block. In RAID level 4, in the case of write, suppose if it is a large write, that is, we are going to write more amount of data. We are going to write more amount of data, then we have it may require to access all the disk. In such a case, it is very easy. We can write the data in all the disk and at the same time we can update the parity disk also. But if it is in case of small write request, then actually we can store only in one of the data disk, but the parity is depending upon the other data disk also. So what happens in the case of small write request? just require 4 disk accesses. So one is to write the new data and the other two to read the old data, and also old parity for computing the new parity, and one to write the new parity. So because of parity is depending upon the existing data, also we have because or write a small request, that is a small amount of data only. We are writing may or supposed to access the disk where the meeting the data and also the corresponding disk and the parity also. And at the same time we are going to update the parity bit also. So these all things may be considered as 4 disk accesses, and here we consider disk as read, modify, write procedure. Now in the case of read level 5, a small difference when compared to the read level 4. In the case of read level 4, we are maintaining the parity in the separate disk actually, that is redundant data in a separate disk. But in the case of read level 5, it will be distributed amount of all the disk. So here there is no specific disk what we call as redundant disk or parity disk. Basically, so what happened here is block 0, block 1, block 2, block 3 parity will be calculated and stored in the last disk, and block 4, next is block 4, block 5, block 6, and parity will be calculated here and stored in various blocks. Parity, a different type of parity is stored in different type of blocks. So like this, here the parity is stored in various blocks, actually. So now read level 6, the number of disks that can be recovered is increased to 2 in the case of read level 6 when compared to the previous read level, that is 2, 3, 4 and 5 actually. Now is this possible? Nothing but by increasing the number of redundant disk or arrays instead of one disk array. We are increasing into 2. So here instead of parity, what we have in the case of read level 4 and 5, also 3, we are using 2 different parity calculation here in the case of read level 6. So 2 different parities. Normally what will be used in the case of read level 6 is general parity, even odd parity can be maintained, and the other parity, that is other redundant code, is nothing but the read on data and code that is followed actually. So here P we can say as parity. And Q read all element data. So block 0, 1, 2, 3 parity will be calculated and stored here. Read all element data code calculated and stored here. So similarly distributed as in the case of read level 6, it is a bit complicated one in order to rectify the data. And here we can see that there are 3 different kind of loss of data. First case, loss of 2 parity disk. Let's say that these 2 disks are lost. So what happens? Here 2 parity bits are lost easily. It can be recovered because data is already existing. And then Q here, and block, that is one data block, and read all among code lost and two data lost. So here what happened? We should be to recover both the data block, and using two data blocks and two parity blocks, here using parity and three blocks, that is recover q and block 7, and here it is calculation required actually. Thank you.